Okay, welcome once again to the Intro to Polar. We will be now focusing on changing to the other form, going from Cartesian or rectangular coordinates to polar coordinates. So let's begin. So we found that in our other lesson, the relationship between polar and rectangular, of course, being if you have a point here, there's an r and a y and an x and theta, all in this one point. You're able to express it in terms of x and y or r and theta. Now, using this, we found again the relationship between these variables. Now we found that x was equal to r cosine theta and y is equal to r sine theta using trigonometry. Now let's take a look at an example. Say we had 2x minus 3y is equal to 5. And we wanted to change this in terms of r and theta to polar coordinates. We would use the relationship we know of and substitute values. So we know that x is also equal to r cosine theta. So we can substitute x for r cosine theta minus 3, and we know y is equal to r sine theta. So we can substitute y with r sine theta, which is equal to 5. Okay, now we will be solving for r. So we know that both of these have a common variable of r, and we can take that out and do r quantity 2 cosine theta minus 3 sine theta quantity is equal to 5. And now using our algebra, we can solve for r, which is going to equal 5 divided by 2 cosine theta minus 3 sine theta. So there's one way. And now we'll be looking at another example, but a little bit more complex. Okay. So now we have y squared is equal to 2x. And now we'll be solving for r once again, using the relationships we know. Now, y is squared, but we still can substitute y with r sine theta. So we're going to do that. So we're going to take quantity r sine theta, quantity squared, is equal to 2. And once again, we can substitute x for r cosine theta, r cosine theta. Okay? So now we'll be solving for r. So we can distribute, and we will get r squared times sine squared theta is equal to 2 r cosine theta. And dividing by r on both sides, we will be left with 1 r, canceling on the right side, and leaving us with 1. And now you have r sine squared theta is equal to 2 cosine theta. And now we're going to isolate the r, and we will get r is equal to 2 cosine theta divided by sine squared theta, which can also be expressed as r equals 2 cosine theta times cosecant squared theta, since cosecant is 1 over sine theta, and cosecant squared would just be 1 over sine squared theta. And that is, once again, the relationship between rectangular and polar coordinates. Okay, and now we're going to look at going from polar to rectangular using the same relationships we know. Okay, so say we are given r is equal to 6 divided by 3 cosine theta plus 2 sine theta. Now it looks intimidating at first, but we know what we need to do. We need to get rid of this fraction here and then see where we can go from there. So let's cross multiply and put this denominator on the left side. So r quantity 3 cosine theta plus 2 sine theta is all equal to 6. Now, we know that r cosine theta is equal to x and r sine theta is equal to y. So now we need to put the r next to we have to multiply the r to the cosine and sine theta to simplify to x and y. So we're going to do that. 3r cosine theta plus 2r sine theta is equal to 6. And now we know that this here is equal to x and this here is equal to y. So now simplify. 3x plus 2y is equal to 6. And now we solve for y and we get 2y is equal to 6 minus 3x and divide by 2. You will get y is equal to 3 minus 3 divided by 2 x. And that is how you change from polar to rectangular and rectangular to polar.